Here, we start right here to create the India conceptual mass model. It's which one? Family 75? No, not this one. 74. Okay, right here. You see, I have to hide this category over here, and you see there's a reference line over here, and this line is the refer to the central point of the shape, different shape, and is attached to the intersection of two reference plane. In this, you can see there's two reference plane right here, and this point there are 56 points on the reference line, and it's separated into 555 parts where the floor plans will be at. So next we'll go to create a adaptive conceptual mass model. You see right here. This one, the generic model adaptive. I already got one. So right here, you can see this is the shape of the floor plans. I mean the floor slabs. So there are three reference planes over here, and all you have to do is creating the reference lines for the shape, like the shorter axial length right here, and the shorter axial length and the longer axial length right here, and set them as a parameter value. It's an instant parameter in here. I call it A and B, and you can see the value is has already been set, so it can be changed. What we have to do is creating the reference lines for this thing, and constraining into the plane, the reference plane, and also we have this have an angle, certain angle to the reference plane. Okay, I'm creating the reference line right here. I should just show you how to do it. And this reference line is actually created before the shape has been created. You can see there's a length annotation right here. We can add a parameter to it. Add a parameter, set it as A or B or C, anything you like, and this length, give it a value, whatever you want, and also the in order to make this reference line turning, we have to constrain this to the one point to the two reference plane. You can see this one is already been constrained. So if this point, this end of this reference line have been constrained, so the other end can turning in a certain angle. So we already have this reference line over here, and we have this turning angle annotation right here, and it has a parameter. It's called the rotation angle. So you can change the angle, and the ellipse will turning You can see there's a formula. It's arctangent formula according to the value h, but you can't see the h in the model because it's just it has to do with the points in the conceptual mass model right here. No, this one. So the ellipse shapes will be put on the other points, and it has a certain value of the h. So when the height changes, and the shape will turn. You see in the type probably, in this type property, I can show you how I control this. If I change the value of this h, like suggest is 100 feet. No, it's not right. 100 feet. Apply. You see that the shape has changed into another angle. So that's how our building form works. And you also notice there is a t parameter over here. It's a type parameter. You can change it into different values, and it's multiplied at the end of the formula of the rotation angle. So actually, when we have this t, we can change the building form directly, automatically. Let me go to the conceptual mass model and review everything. Okay, so we have this shape right here right now, and it has a certain angle of each floor. But if we have the t, then we can just simply change the value of t, and all the floor plans will turn into another angle, and that's how it works. So it will turn into automatically turning model. Let me go back. So we can change this t into 1.5 or 2, and the building shape will be different. And then all we have to do is load this model into the conceptual mass model, which is family. Right here you can see a duplicate from the very base to all the way to the top, and then set right here, and then set the value of h of each floor right here. You can see this is the second level, and set the height into 20 feet. So the angle of the floor slab will turn into a certain angle, and when I do each of the floors, and it will turn into the angle which I want. And then we load it into the project 1 right here, but I'm not gonna do it right now because I have already got one here. As you can see, actually I made a mistake, but it doesn't matter. I can use another way to create the curtain wall system right here. The first thing I'm gonna do is creating all the elevation levels. You see, according to each level, the height of each level of the ellipse shape in the conceptual mass model, so we can view our floor plans in the plan view. Let's go to level 1 and you can see there. We can see the outline of the floor plan, of the floor slab, and then we can create a component, put in a component, and it's a model in place component. We can use blend. No, don't save. Okay, we can create a casework. Which one did I create? I think it's curtain walls. Oh, right here, walls. So you see, this has, I've already created 55 this curtain walls, and this is the 56. We can use the model lines and to find out the outline of the floor slab and offset into the outlines of the bottom of the blend blending component shape, and it will be turns out to be the curtain wall system. And this is just the bottom outline, and then we go to level 2 and edit top, and to create the top outline, and then all we have to do is just changing the material into glass. Oh, but there's another thing. All we have to do is just cancel this. Here we have to change the material of the floor slab, but actually I changed in the I set the materials in the conceptual mass model right here. Click on this one. Okay, you can see the material is concrete precast. So we load it into this project now. Project 1 right here, and we can render, have the different 3D views and making renderings out of it. And that's it. Thank you.